So welcome. And as the custos appointed by the doctoral program committee of the Aalto University School of Arts, Design and Architecture, I declare this public examination open. Today, Ashish Mohite will defend his doctoral research titled Speed-Based Additive Manufacturing Techniques, Discovery and Exploration of Design Potentials of Speed of Deposition in Additive Manufacturing. I also like at that time to welcome the opponent, Professor Małgorzata Spońska from Chalmers University of Technology in Gothenburg. And I think without further delay, I give the word to Ashish, who will start his introductory lecture. Please go.
Honored custos, honored opponent, ladies and gentlemen, this thesis is named as Speed-Based Additive Manufacturing Technique, Discovery and Exploration of Design Potential of Speed of Deposition in Additive Manufacturing. The overarching topic of this research is generative potential of manipulating fabrication parameters in additive manufacturing. The first research question is, what architectural implications are latent in AM fabrication parameters, just as speed of movement? The second research question is, how can fabrication parameters be instrumentalized to produce specific effects? It is named speed-based additive manufacturing technique because the main variable under the study is speed of material deposition, comprising of speed of printer movement, material flow rate, and geometry of print path. When the speed-based technique is utilized in AM, what is the result and the effect is massing variation at surface scale. What does that massing variation at surface scale means? First is textural effect, and the second is influence of small scale variation on structural performance. The aim and objective was to develop an essential structure for speed-based additive manufacturing technique by determining most prominent relationships, causalities, and dependencies within speed of deposition and between it and other elements of production systems. The first objective was to design a generic production system consisting of material, AM fabrication, machine, and G-code. The second objective was to experiment with process of G-code by iteratively changing parameters that constitute speed of deposition, determine relationship between them when manipulating mass distribution. This was presented in paper number 1, which is named as the making of undesignable textural effect. It establishes primary principle of speed-based techniques through experimentation with the FDM and FFM in plastic. The objective 3 was to test the performance of the system where other main elements, material, and the machine are replaced, compare several variation of the terms of printed results and necessary adjustment to the system and production process itself. This was presented in paper number 2, the material agency in CAM of undesignable textural effects. The fourth objective was to design and execute a series of experiments to determine possible architectural application of the technique. And this was presented in the paper number 3, which is called a speed of deposition, vehicle for structural and textural expression in CAM. In the larger context, research is positioned within the area dedicated to discussion on a relationship between technology and architecture. As a space of investigation is an extension of design towards making through technological means of digital fabrication. In the terms of pre-digital argument, Robin Evans, with translation from drawing and building, he's asking a rhetorical question. Can the gap between the drawing and building be breached? He's uncertain the way to unite them. Now, with permeation of digital technologies throughout both design and construction, architecture provides opportunity for that unification. In the first digital turn, exploration of new technology through CAD happened. Technical dexterity seemingly widening the gap between the drawing and building still existed. So how the digital dexterity seemingly disconnect the world of drawing to building, but digital parametricism, which was developed during this time, became the foundation for the second digital turn, according to Mario Carpo. It is about sudden availability of these tools and exploration. Second digital turn in many ways is building the bridge between the digital and the material, between the abstract and the real. How through the new way of thinking, through the digital means of integrating the machine of making into this process. CAM tools of AM was chosen. So additive manufacturing tool was chosen to investigate. Most common additive manufacturing techniques in architectural practice are 3D printing with plastic. So example of a pavilion by ACT Lab, 3D printing with metal welding robot. Example is MX 3D bridge, and 3D printing with clay or earthen clay is example Casa-Covida by emerging objects. At small scale AM is a research method used in ideation, concept creation, and research. Another example of this is again from emerging objects, the project G code. As example of this translation of scaling up the small scale AM experiments of emerging object is the project Casa-Covida. So this was an example which scaled up the small scale experimentation into an architectural scale. Now, after establishing the area of inquiry into architecture and technology, more specifically AM in architecture, we can look at craft. Craft is a practice ruled by certain principles and procedures was chosen as a theoretical framework to guide this research. The emphasis here is on the process because research is explorative in nature. To summarize, craft is a practice characterized by constant development of skills to master materials and tool in order to produce an object whose function is to point out something beyond itself and whose value is variation. For the purpose of research, the main principle of digital craft is that it constructs the process of making, and what remains after completion is a trace of negotiation between digital and the physical. If we try to break down the craft, what craft means in contemporary discourse, the method would be iterative experimentation, the medium will be materiality and tools, the result will be object of supplemental nature, and the lens of practice will be balance between the skill and risk. The adoption of CAM has brought idea of craft in architecture. Principle of craft, which are present in the craft in general, apply in architecture. However, those tools specifically of CAM, I would like to discuss several aspects of digital craft in architecture, which will inform the methodology. Now I would like to discuss digital craft in terms of specific aspect, which would later inform the framework of CAM, implies in certain continuity between design and making as described above. Continuity of authorship is the first one. Skill. In digital craft, the focus often lies in discovery and developing virtuosity in operating the means of architectural production, computer, software, machine. The skill lies in the designer's ability to tweak the underlying system. Object as a process model. So we are no longer, according to Gramazio and Kohler, we are no longer designing the form that will be ultimately produced, but the design process itself. The forming and structuring of material has been replaced by flow of information. Digital materiality. So this was a term coined by also Gramazio and Kohler, where digital materiality is not rooted solely in material world and its physical laws such as gravity and material properties, is enriched by the rules of immaterial world digital logic, such as procedural nature or calculatory precision. Risk. The original argument by David Pye on integral connection between traditional craft and risk is been brought back by Branko Kolarevic, making it as valid for digital craftsmen as it was for the 19th century basket weaver. Surface variation. Semper brings the mean of production into architecture. For him, technique making leaves the trace and original means of making gets rethought, and ornament is the trace. So in summary, digital craft aspects which are discussed, they form the framework, which will then inform the methodology. But if you think about the practical precedences in this digital craft, I would like to give some examples. So the first would be continuity of authorship. The example is Ronald Reel and Virginia Sanfratello from Emerging Object. The focus is on generative potential of toolpath manipulation in G-code clay object. Tweaking the way the printer moves, they introduce deviation in the system defined by the plasticity of clay, gravity, and machine, which produces undesigned yet reproducible surface variations. Skill. By utilizing machine learning and robotic carving, the process force feedback, Giulio Bergano and Hanna were able to teach the robot to adjust the pressure and direction of the cut according to the specific material behavior. Object as a process model, in Andrew Atwood's monolithic representation, His concern is with the limit of architectural object, seen as aggregation of parts, but as a monolithic means of organization. He's injecting anomalies into the standard process of plastic 3D printing. In the case of digital materiality, the project from Grammasticola Research, a low aggregate is a collection of undesignable realities, where the robotically performed impact of projectile is translated through matter offset through various uncertain factors, such as air pressure, projectile weight, robot positioning, repeatability. Control and risk. Zach Cohen has developed a pointillistic time-based deposition technique of robotic 3D printing with cement. In terms of my work's overall objective and technique itself, Cohen's work is the closest to the research. However, his focus lies in instrumentalizing the inevitable tension between the speed of machine and the speed of material. Surface variation. So Bernard Cache explored consequences of changes in tooling paths for CNC machines. Most of the above projects overlap within the various aspects of digital craft. For sake of simplicity, I have put them in one as a one process itself. Formulation of the theoretical framework. The process model is the object of design containing multiple types of information organized in a structure of relationship. Concurrently, it is an apparatus of training skills, which lies ability to employ the causality between parameter changes and material deviation for design purposes. And adjacent to digital craft concept of digital ornament, provided a way to analyze the results, first of all, as imminent to the technology trace of making as a tool for future development. The formulation of theoretical framework, if you think about the gap in the current theoretical framework, there's lack of research on generative potential of manipulating fabrication parameters. There are no creative solutions to printability issues. This research attempts to contribute to the knowledge by addressing these gaps, by by building upon the principle of additive manufacturing and digital craft and translating them into guidelines for methodology. The main research question revolves around discovery potential of architectural application, benefits, shortcomings of a device technique for manipulating speed of deposition of AM machine. The aims were to question the technique in various lenses: material tectonics, constructional, and ornamental. The methodology was divided into 3 phases: discovery, exploration, and testing. In the discovery phase, the discovery of speed-based technique through open-ended experimentation with plastic FDM 3D printing system was made. Observation and interpretation of results were documented. In the phase of exploration, exploring the speed-based technique by creating a digital algorithm that then is used to drive a series of rapid prototyping tests in 3 different fabrication setups, FDM, PEM, and WAM, were made. Attempting to understand the relationship between the technique, machine, and materials were made. Critical evaluation of scale models, interpretation of the outcomes in the framework of question was created. Iterative editing of the system and technique was performed. Testing. In the last phase of exploration, testing speed-based technique for design application in ceramic PEM 3D printing systems, specifically its potential in resolving certain printability issues, such as printing a tall, thin object, cantilever geometry, and bridge geometry was performed, reflecting on the performance of the system in terms of ornamental effect and printability improvement. And the result of reflection encapsulated in the design of the digital design process with guiding intention of increased universality of the system application. In the methodology, the strategy was designed by research. Research by design is a research approach that aims at creation of knowledge by extending methods imminent to design as a means to link theory and practice. The tactic which was used was iterative prototyping through AM. This research utilizes an explorative tool similar to Thomson-Tamke's material prototyping, consisting of parametrically driven, continuously evolving G-code, additively manufactured in a setup of material machine into a series of physical artifacts. The basic principle is that the printer is designed to go in a certain area faster and in certain area slower. The faster the printer moves, the less matter it deposits. Therefore, by making the printer faster and slower, we can manipulate the massing. So the basic principle is that certain segments or areas of the object are extracted and the speed of deposition is either increased or decreased. The system design was in three parts: machine, material, and design and process. For the machine, for plastic printing, Ultimaker 2 was chosen. For ceramic printing, printer was built by me. And for metal printing, used a setup for metal welding robot with KUKA. The materials used was PLA plastic. Porcelain recipe was developed for 3D printing, and steel metal cable was used for metal welding. If you look at the typical process of how 3D printing works, this is a workflow from Cura, where user has no freedom. Process is extremely straightforward, doesn't allow deviation, and does not give creative freedom to the user to change the process of making. This diagram represents the starting point of the research. I took a straightforward 3D printing preparation process and added few variables, few degrees of freedom to it. A large series of models were printed, and a new informed digital process was created. This diagram is the process at current stage, which was informed by experimentation. It is more refined than the basic setup, and this will be further developed in the future. The result of this research follow from research question: the main architectural implication of using speed-based technique as undesignable textural variation and improvement of geometrical printability. According to the stated objectives, following results were achieved. A production system comprising of machine, material, and process model defines where and how printer moves and deposits. It's constructed as platform for speed-based technique deployment. The system is treated as set of parameters, capacities, and properties. By interacting, they form secondary performative aspect of the system, which affect material deposition in printed models. For example, the mass generated at given location is determined by material viscosity, machine nozzle diameter, value and continuity of speed of movement, and geometry of print path. The work is instrumentalizing textural surface variation into tool for aiding in printability of overhanging, lanky, bridging elements in PEM is based on extending the range of acceptable deformation beyond surface scale. At surface scale, the result is ornamental formation where expansion of the object level alters initial geometry sufficiently to provide localized tectonics and structural support. The main objective of the speed-based techniques are heterogeneity and precision of mass distribution, control over the process, diverse textural variation, and improvement of printability of unsupported geometry, continuity of logic and control between design and production. Furthermore, the amount of additional mass needs to be carefully offset by mass suppression. Otherwise, material expenditure and machine hours will increase dramatically and render the technique unviable in commercial setting. There are some negatives of the system, such as it deforms the shape, it produces additional mass, it produces additional print and execution time, and it structurally weakens ceramic. But as I said, that it needs to be carefully offset by mass suppression. Otherwise, material expenditure and machine hour will increase dramatically. Practical applications and future research. For speed-based technique to be most advantageous, it needs to be utilized in a design and research environment where minor discrepancies between design and execution is acceptable and mass allocation is really relatively unrestricted. For example, artificial reefs, walls, and columns. Here is an example of artificial reefs 3D printed in concrete. The main contribution of this research is to knowledge, that it provides the foundation for an apparatus to practice additive manufacturing in a generative and a meaningful way. The technology itself is engaged as a design driver. Surface variation is an expression of making, and while having an aesthetic value, it also is a way to strengthen or weaken structure locally, increase and decrease the surface area between the layers, and print unsupported parts without any support. Thank you. I ask you, honored opponent, appointed by doctoral program committee of the School of Art, Design and Architecture, to present the critical comments on the dissertation you find well-founded.
Thank you very much. I will start by presenting a brief statement on the positioning and significance of the work.
Sorry, I did not hear her.
Can you hear me now?
Sorry,
Hello?
I can hear you, but Ashish cannot hear you.
Okay.
Well, just a second. So I think now you.
Can you hear me now?
No, I don't hear you.
Can you say something?
Hello. Can you hear me now?
No, I need to change something. Give me a second.
Sorry. Yeah, we need to change some settings. There is some problem.
Disconnect.
Okay. Just switching the computer, sorry.
No problem.
Now he can hear you. Okay, go ahead.
Yes, you can hear me?
Yes.
Okay. Thank you very much. I will start by presenting a brief statement on the positioning and significance of the work. And afterwards, I will continue with the questions that I have to your work. The presented work is positioned within an area of architectural research known as digital architectural design. This area is well established and represented by 4 international associations for computer-aided architectural design research: the European ECADI, the North American ACADIA, the South American CICRADI, and the Asian CADRIA. 2 conference papers constituting the publications of the thesis were exposed to peer review by one of these associations, the European ECADI. This fact points at a clear link and relevance of the work to the research area of digital architectural design. The main outcome of the study is a design and manufacturing approach featuring layer-by-layer material deposition in a non-standard manner based on intentional regulation of the speed of deposition to achieve both original aesthetic effects, but also enhanced material stability. The approach was developed by applying an established method of architectural research, namely research by design, in which the creation of new knowledge was achieved by the researcher entering the process of designing hands-on, with the main knowledge sources being the workflows and artifacts developed by the researcher. The study at hand builds upon existing findings and precedents within the area of artistic 3D printing. It progresses the current state of knowledge through an in-depth investigation of a selected number of material, geometric, and machine parameters to determine how they can help to achieve specific aesthetic and performative effects in architectural elements. The main originality of the finding resides in the definition of a design approach represented in methodological and operational schemes. These schemes, in my opinion, enable further studies and future applications in architectural practice. The disciplinary value of the proposed design approach resides in its capacity to incorporate erratic material phenomena. The conceptual arguments of the work are supported by a recollection of existing discourses, theories, and precedent projects, representing 3 important themes in contemporary digital design research. These themes are material agency, digital craft, and intentional glitching in computing. As such, the work unites these three perspectives by arguing for an extension of established applications of additive manufacturing in the construction industry. Through architectural models and design workflows, the work exemplifies how the purpose of additive manufacturing can be shifted from exact representation of designed models to its employment as a design exploration tool. As such, the work reveals that additive manufacturing could seamlessly bridge the gap between design ideation and materialization, marking the return of craft in architecture in a new digitally aided form. So now I will proceed with the questions that I have to the candidate. And the aim of the questions will be to stimulate a scientific discussion on those aspects of the work that I have found worth highlighting and discussing further and elaborating on. And my first question to you would be on how you would see the positioning of your work within the field. Because today in digital design research, we can observe two main trajectories or two main purposes. One purpose or tendency would be to strive for ultimate computational control, high precision, high performance, and optimization. An example could be the notion of cyber physical control systems introduced by Aki Menges from the Institute for Computational Design in Stuttgart, where what is being done in the process involving erratic material behaviors is that one would use real-time sensor feedback on the dynamic material behaviors in order to on the fly adapt the path of the machine to those behaviors to achieve a high level of control. And then one could say that there is also on the other side a second approach that would actually argue in the process or almost entirely to boost the creative and artistic side of computing, to trigger intentional glitches and imperfections, both in the way that we compute, but also in the material artifacts. And one could say that an example of this train of thought or this trajectory is the Acadia 2018 conference, which had as its main theme recalibration, and it focused on imprecision and infidelity. But there are also a number of writings and publications on this, such as the book Lineaments by Gail Peter Gordon and Michael Meredith that you may perhaps know. Since your study employs the research by design methodology, and this methodology also entails introducing a personal designer approach and a personal outcome, it would be very interesting for me to know how you would see your work if we would say that there are those two trajectories, one that aims for ultimate control and the other that aims for an artistic articulation and actually letting go of that control. Which one would it be?
You hear me now?
Yes.
Yeah, so in my approach, the main idea was to design actually the process itself. So the process of design, so like starting from the argument of technology and architecture, right? So architects were making drawings and then the buildings were made based on those designs. And then the first, like when the digital tools started proliferating in architecture, we started we started using digital softwares. And then again, we were still making notations into computers. And then those notations were then translated into buildings. But now, as you gave examples also like Akim Mengis's research, there is a whole system design, right? There is a tool, there is a material, and there is a software. But then they look at it through the morphogenical landscape, for example, like morphogenesis, through the lens of that. I looked at it the same thing. So like I had the tool, I had the material and the software, but then I looked at it from the crafts perspective, because for me as a maker, craft has a very important position within the process of making, because I'm interested in the process itself. I'm not interested in the outcomes as such, because the process will derive the outcomes. So I agree on the both points. Actually, at this, I'm also trying to develop now a system where there's kind of a real-time feedback, and how that real-time feedback can change the tool path of the robotic arm. So that is something which is already going on as a research trajectory from my side. So this is something which I'm already doing, and I always think this process itself is the generative process. So that's why I think the system design where the robot is like learning from machine vision and like changing, this is something which I see personally going towards.
Mhm. Thank you very much. If you could elaborate a little bit on what you mentioned, that it's for you, it's more important about the process and not the outcome. Why do you think the process is more important than the outcome?
Because I also believe that in architecture, it was all about the process, where we were making the drawings. The drawing was the making for architects, right? So because architects themselves were not making, they were makers of drawings. And now I see digitally, the architects also, like the argument from Mario Carpo, that we are making digital notations. And now, because we have machines, we can actually make those digital notations and bridge this gap between the making and designing. And that's why I think I'm important, like, again, the process is very important, because the process of notation is where we have the most creative freedom as architects. Because then the tool, material, and physics will again inform that. And this is where also the digital materiality comes into the picture, where the material informs the process, and it becomes like embedded with information and become charged. So that's why I think that the process itself is very important.
Thank you very much. Then a second question I would have to you is on your contribution to architectural theory and discourse, because I really appreciate that you have made the attempt to actually construct a theoretical framework or a collection of concepts from architectural theory and discourse that you then use as your foundation to both launch off your personal work, but also use it as a foundation to motivate some of the decisions that you have made during your research. And it is often said that if one employs the methodology of research by design, ideally one should contribute not only through the making of the artifacts, but also through the contribution to the current discussions that are going on in the discipline. So I was wondering how you would formulate your contribution to that ongoing discussion and this theory and discourses that you have also addressed in your theoretical framework involving digital materiality, and surface variation. You have those concepts that were a part of it.
Yeah, I wanted to position my work for, like, if you see the work as what, I wanted to position why. Because why I am doing what I'm doing was very important, and I'm trying to establish that within the realm of architectural theory and discourse and what it means to architecture. Because in the end, I'm an architect, so I would like to use the research and the experiments which I have made, and to see what is the potential architecture. So we have to question, like, what is the potential in architecture and why it matters within the field of architecture. And I have been closely following the discourse within the digital fabrication specifically. I have been to all the conferences and know the current discussions of what's going on. And I feel that I fit within the niche of digital fabrication processes, or because most of the digital fabrication is about the tools and the outcome. And I am more interested into the process and not the outcome. And that's why the craft is important, because I'm looking craft from the lens of the process and not as the outcome of an artifact. Artifact or the outcome is supplementary, or if you would like to put it in like a Bernard Cash's theory, it's like an objective. It has the potential, but I'm not designing the final form. The potential is in the process. And that's what fascinated me, the process, and to design that process. I don't know if I answered that question, but this is my position within the discourse of digital fabrication.
Mm-hmm. And do you think that you are introducing any new concepts or terms related to the discourse that that either bring something new to the table or present an alternative outlook? If you could elaborate a bit more on that.
Yeah, so I think from the technique point of view, this is a novel technique. So as far as I know that nobody's doing like speed-based additive manufacturing. The closest is example, which is also there in the book, like Zachary Cohen, and he's talking about the machine delay and material and delay, not specifically about the speed of the movement per se. So this is something in terms of technique, novel. And what I feel is that digital craft currently in architecture doesn't have like a strong theory base. Like, what does it mean? In most of the cases in architecture, digital craft means that I use a computer to design and I use the machine to produce it. And that then qualifies as digital craft. What I try to do is those 6 parameters, and my argument would be, if it has to be called digital craft, then it has to have all this object as a process model, continuity of authorship, scale and risk, surface variation. All this has to be there in order for that object to be called as a digital crafted object. So this is something which I think is novel, that nobody has tried to like look at this whole process from the lens of digital craft and try to formulate an argument. What is digital craft in architecture and what does it mean?
Yes, I think that's a very good answer. And also, I think that since I have read your publications that that you appended to the thesis, I think that you could still think of a future publication that addresses exactly that gap, that theoretical gap, that you do make that very explicit through a publication, that framework that you have built consisting of those 6 different concepts that you just mentioned. I think that this is something worth publishing, or at least emphasizing even more in your work. And I also think that in the first of your papers, you actually introduced the term of regulated workmanship. That is also a part of your contribution to the field, I believe. And also this notion of undesignable effects. Even though you say that you are interested in the process, I think that this byproduct, as you see it, the aesthetic effect, and that the fact that it's undesignable, this is something for sure worth coining from the theoretical standpoint, because these aspects haven't been really explored in the current literature, both in terms of the practical work, as you say, that addresses the material, but also the aesthetics. This isn't really formulated. You just see images of the artifacts, but it's not really discussed in depth. So I think that this part of your work is a valuable contribution that you should strive to continuously underline through publications.
Yeah, thank you. I actually was musing about this surface variation and ornament, and then I started thinking that this is also a large body of work to undertake. So this is something, of course, I'm gonna keep on exploring, because this is also something which is very much of interest of me.
Yes. Okay. And then I have a third question. You actually touched upon this a little bit, but when it comes to your contribution in the context of the chosen precedent studies, you have coined that there are several projects along a similar trajectory. However, projects are the studies by Andrew Atwood, Benai Gursoy, and Zach Cohen. So for me, it would be really interesting if you could right now discuss a little bit more in depth how your work differs from these precedent studies. What are you bringing to the table in relation to what they have brought? Of course, it can be also that you are approaching something using a different methodology. It could be that you are approaching the subject from a more practical perspective, or any other aspects. Maybe you have coined more in depth some aspects of the manufacturing process, something that the others haven't done. So if you could take each study one by one, starting maybe from Atwood's study, then following with Gursoy, and then ending with Zach Cohen. How does your work differ from these studies?
Yeah, so thank you for the question. I think only Andrew Atwood's work predates my work. Both other examples are a little bit later. So I was actually doing the speed-based technique much before Zach Cohen and Benoit Gursoy, at least in terms of when they were published. So in terms of the research, actually, Andrew Atwood works was the one which I based my experiments on. So that was something which I saw and was very interesting for me when I looked at this kind of monolithic object. And when I started looking at it closely, what I understood that, first of all, I also started using plastic 3D printing. But Andrew Atwood hasn't documented exactly how those printed objects were actually produced. Was there manipulation at like the process level itself, or the G code which was generated by a slicer was then modified to produce? So that is something which is different. So the monolithic representation, the looping which you see, that is something which you can do as a special setting within Cora. This is something which you can also do. But I do not see any well-documented series of experiments. So there are few models which are published and which are known to public. And they seem to be like the end of a process, and the process was not specifically clear. But then in his case, the effects were like part of the discovery. And for this research, they are the part of the method. So in my case, the effects are part of the method, and his case, it was about discovery. So let's do that and see what happens. And in my case, it was more of a like a, let's change one parameter at a time, print several models, then see what happens, and then change parameters and again continue. Another what I have also written in the book about that, again, like all three works which you mentioned work with one material. So each of them have chosen a specific material. What I try to do is trying to use the same method in 3 different materials. And now I'm using also the method in concrete. So that's the 4th material, which is the part of the future work. And I'm trying to compare these 3 materials using the similar speed-based method, using even the same speeds, and then comparing the materiality and how the speed change and the material changes the way the object is produced, and if the process has to be manipulated. In Gursoy's work, the difference there was actually no speed-based technique. What she explored was changing the layer height, the nozzle diameter of the printer, and then documented the results which were produced from that. And now I think what I know from her presentations is that she's continuing that work into the next level. So this was like a preliminary test of certain print parameters, which are basic print parameters in any 3D printing software, and then checking how those print parameters and changing those print parameters, keeping the same material, produce different results. Zach Cohen's work is actually the closest to the research. I came across this work in 2018 in Robots in Architecture, where I saw his presentation. I think that was the first time his paper was presented, which is also part of his master thesis project. I have been doing experiments in speed-based technique since 2016, published first time, but I have been doing them before. And the difference between his technique and my technique is what we are trying to explore. So what he's trying to explore is this notion of machine delay. He's interested in time. So if you see his presentation, he builds the idea of delay in architecture and how this delay could be used as a process of design. And then he uses the machine delay and material delay and tries to negotiate between that. And then he produced this kind of artifacts, which are walls. And recently I have also seen a work where he was producing a column using similar technique. So that's the difference between their work and my work.
Mm-hmm. I think it's also a very good answer and a good and a good summary of the differences. And the reason why I asked is that this could be something also to use in the future iterations of your work, to make your positioning within the current works more clear, so that your contribution is crystal clear to those who are interested in general in the developments within current research on similar topics. That is why I was asking about it. And I think that, yes, I mean, maybe it matters less at this point who did first what, and probably two people doing the same research in two different parts of the world will do it differently, even if a subject is similar. So it's more about when you present your work in the future, to make that really clear, to really map out what the others have done and what your specific contribution is. And I think that this exercise that we did right now will be very useful in making that even more clear. So that is basically what I wanted to achieve with that question, to encourage you to be much more to the point.
Yes.
In the future.
Yes, thank you. I have also had discussions with Bena when she was presenting the paper in ICADI in Poland, I think, if I remember correctly. And with Zach also had a discussion about his technique, and we discussed what are the differences and like what he is interested in and what I'm interested in.
Yeah, and I think it could also serve as a very interesting mapping of what is currently going on. So if you publish a future paper and you present this background, this will be very interesting and also a very valuable contribution to the current knowledge on digital fabrication as well. So it's really good that you are also in contact with these researchers and know the details of their work.
Yeah, I don't know if you know, but Benoit Gursa was also a pre-examiner for this thesis.
Okay, that's really good. All right, and now I have a couple of more questions. I wanted to ask you about your research output. So you, in a series of diagrams in your results section, you present general schemes showing different bits and pieces of information regarding the technical setups and parameters for the speed-based process. And you try to keep it at the meta level. So in the sense that you are actually also in your publications and in the introduction to the thesis, you're not really showing any grasshopper scripts or parts with the silkworm components. You seem to deliberately not present that, but instead present your work at the level of a more general theoretical framework. So I wanted to ask you why you are not showing any of the grasshopper scripts, because one could argue that maybe if you make those scripts public or available, then that would make it easier to apply your findings in the architectural practice to make them proliferate in the field, or it would also maybe be easier to conduct further research on the subject by other people. So why in principle did you choose not to show the grasshopper parts?
Well, that decision was not very deliberate, but the idea was again about what I wanted to show why and how, but not specifically how. So the Grasshopper scripts were also taught first in a workshop here in Alto. So there was a 1-week workshop where we taught students the speed of deposition method in digital fabrication course. And then what was interesting is that they came up with like even new methods. So I only showed them like the basic principle is that certain if you divide the curve in a certain way and if you give different speeds to those parts of the curve, you can use the speed-based technique. And the students actually came up with new ways of using this technique just by having the knowledge that changing the speed creates this kind of unintentional effects. So I thought it was like very interesting because I only introduced the process. I never shared any Grasshopper script with them, but it was very easy for them to understand. And the same happened in Odense in Denmark last year, where we did like a concrete 3D printing workshop, where also the students were introduced the speed-based technique through a PowerPoint presentation. So not even like Grasshopper scripts, but students were able to understand and grasp the logic and were able to create their own scripts and were able to replicate similar processes and effects in concrete 3D printing. So that's why I thought it was interesting, like not to give exactly how to do it, but lay the groundwork of how to do it. And then using that, maybe there will be more branches which will come out of it and it will remain more open. And that was maybe the reason why I didn't include the Grasshopper scripts into the presentation, because I thought that these diagrams will serve as creation of new Grasshopper scripts where the user can add their own knowledge and their own understanding of what is speed-based technique.
I'm satisfied with that answer, and also it evokes further ideas for how you could continue, because what you're saying is actually that the framework that you have created is robust enough to create a variety of effects and a variety of iterations, and this actually in a way validates the robustness and the strength of the work that you have developed. So maybe that is yet another idea for a publication that you could actually try to indicate through your pedagogy and the experiences from that part, that this actually feeds into the research and in certain ways proves the point or shows the different aspects or shows the potentials of how your technique can be developed.
Yep.
Yes, and then I also have one question regarding the summative self-assessment, how you would summarize your work, because of course at the outset and also during your research you had some aims that you wanted to achieve, you had some prerequisites or theoretical assumptions that you have made and that you have verified through your process. So I would like to know how you would summarize, for example, which research aims did you reach, and which research questions do you think that you have addressed successfully, but also what remains yet to be achieved, and how specifically would you continue your research based on your findings?
Well, I believe that most of the objectives were achieved. I think the negative points, as I mentioned in the presentation, that I thought that the speed-based technique will increase the structural performance of the system. And when the ceramic 3D printed parts with the speed-based technique were tested with compression testing machine, it turned out it's otherwise. So that was a complete failure of understanding the material structural performance. But also that is because ceramic material is in many different phases. So first it's liquid, then it dries, then you fire it, and then it shrinks. So that's where it failed. But then with plastic and metal, it still remained that the structural performance of the object was better than without the technique. Another failure was when I tried to connect the Karamba models. So basically the last experiments which are presented in the third paper, where the Karamba model, the structural of analysis, which was directly connected to the speed-based technique, and the speed-based technique was derived from the structural performance. The results produced models which took 5 times more time to print. So then they had to adjust it to reduce the print time, because one of the model took 120 hours to print. So that was a lot of machine time which was increased. So I think what is lacking is like tweaking this relationship between the speed-based technique and the Karamba model and the results which it produces. There needs to be a filter between that, which doesn't exist right now. So there needs to be a filter which increases the time, but not 2 times or 3 times, but let's say 1.2 times. So it increases the performance of the system by using the speed-based technique, but it doesn't make it taxing on the system. So we're not using more material and more time. So that is something which is lacking still. This part is right now investigated, like how this filter could be added to the system to reduce the print time, because now I'm moving the research into concrete 3D printing, and if it has to go commercial, then this time becomes very important in the commercial sense. And so that we don't have the affordance of like having 2 or 3 times than the traditional simple 3D printing techniques. So this is something which is still lacking in the research and still needs to be further developed. So that is, I think, like a negative point one from the structural performance of the ceramic 3D parts, and the amount of time which increases because of the speed-based technique. So this is something has to be controlled.
So when it comes to continuing the research, as I understand, you will on the one hand try to improve some of the parameters that you have discovered that are not optimally set at this point, and you also will change the material to concrete and probably maybe scale up, or
Yeah.
okay. And then you mentioned also something in the beginning about your interest in also including maybe real-time feedback from sensor inputs, and
Yes.
how would that play in, you think, into the process?
Yeah, so the real-time feedback, the existing research in concrete 3D printing already a little bit exists. So in that case, the real-time input was used to reduce the slumping of the object, to correct the geometrical slumping and keep the printing in the straight manner, so the object itself doesn't expand on the bottom. So this is something which I also have discovered with my limited experience in concrete 3D printing, that this is something which exists because of the viscosity of the material at the initial stage, and then that is carrying the weight of the remaining object. So this is something also has a commercial implication, how this real-time feedback could be used. And this real-time feedback could be also used to increase the speed of printing or decrease the speed of printing, or increase the amount of mass deposition or decrease the amount of mass deposition based on the need of the object at that moment of time. So this is something can be deployed. So this will become another parameter where certain parameters will be given to the machine that you can add certain amount of material or reduce certain amount of material in order to correct the path. So this is something it would be implemented. This is my thinking. And we have applied for a research project based on this idea.
Okay, that sounds really interesting. I'm really looking forward to seeing how your work develops in the future. And this was actually my last question. So I am content with the scientific discussion of your work. And I want to conclude by saying that I will propose to the doctoral program committee that the thesis be accepted.
If anybody present wishes to make any comments concerning my dissertation, please ask the custos for the floor.
Are there any questions from the audience? This seems not to be the case. So then the doctoral thesis proceedings are closed. Thanks.